All right, we're going to talk for just a minute about something called indirect proof. And indirect proof is just basically a proof by contradiction. This basically means I'm going to take whatever I'm trying to prove and I'm going to try to prove the opposite of it is true. And when I do that, I'm going to come up with a situation that won't work. And that means that the original statement was true because I couldn't prove it was wrong. I couldn't prove the opposite of it. So start with this statement here. It says two supplementary angles cannot both be obtuse angles. So let's just pretend that we can have that. So what I'm going to do now is try to prove that angle A and angle B are supplementary obtuse angles. So I'm going to start out real quick, real easy. This is my given statement. So I'm going to say that angle A and angle B are supplementary, and that's given. Then I'm going to say the measure of angle A is greater than 90 degrees, and the measure of angle B is greater than 90 degrees. And that is also given right here. I said they're obtuse angles, so no big deal. Then I'll say that the measure of angle A plus the measure of angle B equals 180 degrees, and that's the definition of supplementary. Do a little algebra here. I'm going to subtract the measure of angle B from both sides and get that the measure of angle A equals 180 minus the measure of angle B. Okay, that was my subtraction property of equality. Then, this is where a little bit of experience comes in handy. Right here it says the measure of angle A equals that. Well, up here, I have the measure of angle A. So I'm going to substitute by writing 180 minus the measure of angle B is greater than 90. So where the measure of angle A was, okay, I just rewrote it down here, but instead of the measure of angle A, I put 180 minus the measure of angle B. And that was the substitution property. Substitution. All right, so I'm going to add measure of angle B to both sides and get 180 is greater than 90 plus the measure of angle B. There's another example of the addition property of equality. I'm going to subtract 90 from both sides and get that 90 is greater than the measure of angle B. And that was also from the subtraction property of equality. Now, I've got a real problem here because right here, I said that the measure of angle B is less than 90. You see how the measure of angle B is now less than 90? But way up here, I said the measure of angle B was greater than 90. So I have a contradiction here. That's what this is. This is a contradiction. So my original statement is true. So two supplementary angles cannot both be obtuse angles. And I'm done. Okay? I proved it. I tried to do it, right? I tried to make it happen. Couldn't do it. So now we're going to move on. All right, so I've got a triangle here, and you see this triangle. Down here I have angle BAC, which remember the whatever letter's in the middle is the vertex. So really this is angle A, and over here this is angle C. And I have their measurements out here. So they're both 45 degrees, which means this is an isosceles triangle. So segment AB is congruent to segment BC, 7.21, 7.21. So what I'm going to illustrate for you here is something that hopefully makes sense to you and doesn't require put too much strain on your brain. If I take point B here and I move it around And what I'm going to do is make side AB be smaller than side BC. Okay, so I can do that real easily. Just move it like this. So now you see that side AB is 5.03 and side BC is 8.31. So clearly, this side is larger than this side. And notice what happened to the angles. The angle that is opposite of the largest side is also the largest angle. So between the two sides, now I'm not looking at angle B at all. Nobody cares about that one. I'm just looking at between these two sides. The smaller side is across from the smaller angle. Okay, so that's just something that you know. In a triangle, the larger angle is opposite the larger side, and the smaller angle is opposite the smaller side. You may want to write that down so that you know those things. There's one more thing that we need to talk about as far as triangles go. It's pretty basic. All right, so we have a triangle here that has all of its side lengths already marked. So here's AB, BC, and AC. And hopefully you can remember back to when we talked about what it takes for 3 side lengths to make a triangle. And hopefully you'll remember that we said that AB plus BC had to be greater than AC. So when you look at this triangle that I have here, what we're saying is that AB plus BC, okay, so right here, AB plus BC has to be bigger than or greater than 16.44. And you see that it is, right? I'm adding up AB plus BC. But what happens as those two numbers start to shrink? I'm going to start to shrink them now to where AB now down around 5 and BC is around 13. See how it's getting closer and closer? And what's going to keep happening if I keep shrinking both of them all the way down to where they're equal to each other, where AB plus BC equals AC, you see now I don't have a triangle. And you see also if those two lengths were any less than they were, they wouldn't even touch each other, right? They wouldn't even connect. So this concept or this idea is called the triangle inequality theorem. And the triangle inequality theorem just says that any two sides of a triangle have to add up to greater than the third side. So you may want to write that down. Okay? Your triangle inequality theorem says the sum of any two sides of a triangle is greater than the third side. Is greater than the third side length. So that's all we're going to talk about tonight, triangle inequality theorem. If you look back about the inequalities in one triangle, and then also the indirect proof. So write down any questions that you might have and make sure you bring them with you tomorrow.